This last section is about acid rain, and I'm not going to test you on this, but I think it's useful to talk about. So, we've all become aware that climate change is an issue, right? And we know that combustion of fossil fuels is contributing to that. When fossil fuels burn, they are not pure hydrocarbons. They've got other elements in them, like sulfur. So, especially coal can have significant amounts of sulfur in it. And then during combustion, you form SO2. Well, SO2 can react with oxygen and water in the atmosphere and form sulfuric acid. Is it good to have sulfuric acid floating around in the air? No, it isn't. Another thing that happens is, there's a lot of nitrogen in air. Air is mostly nitrogen. And so when you have combustion of a fossil fuel, not only do you get carbon dioxide, but you can also get nitrogen dioxide. Well, nitrogen dioxide can also react with oxygen and water in the air and form nitric acid. So there we have two strong acids coming as byproducts of the combustion of fossil fuels. Lovely, yes. So, I think you've all heard of acid rain. So that does not mean that, 1 molar hydrochloric acid is raining down on places, right? What it means is that the rain is more acidic than it normally would be. Because as H2SO4 and HNO3 are formed in the atmosphere, it's very natural that they will dissolve in get into the clouds and combine with the rain. And there are differences geographically in where this is a bigger problem. So the Northeast is really taking the brunt of the acid rain, and that's because of the natural air currents. So the natural air currents are bringing essentially pollution from the Midwest, where coal burning is more common than in some other places of the United States. The SO2 and NO2 produced from the coal combustion just naturally blows over to the northeast part of the United States. So this is a lot like how in the valley we get pollution from Sacramento. And then if you go down by the Grapevine, and all of this pollution just blows down to the bottom of the valley, and the air is really thick down there, right? Now, rain is naturally somewhat acidic because there's carbon dioxide in the air, and we just looked at how carbon dioxide and water can form carbonic acid. But carbonic acid is relatively weak. Nitric acid and sulfuric acid are strong acids, right? So natural rainwater is going to have a pH of maybe 5.6, which is slightly acidic. But when you get the sulfuric acid and nitric acids in there, you can get that pH falling below 4.3, and that's a logarithmic scale. So that means the hydrogen ion concentration is 20 times higher than rain without pollutants in it. So what happens when we have acid rain? Well, there are lots of things that dissolve in acids. There are many metals that dissolve in acids. Carbonates are natural minerals that dissolve in acid. And so we see an effect on things like bridges and railroads and automobiles because the metals in those things are going to be very slowly, but they're going to get dissolved by the acid rain. We also see an effect on things like marble, limestone, or cement. Cement is used in statues and buildings and pathways. Marble and limestone have a lot of carbonates in them. And so here is a picture of, I think this is a gargoyle, well, two gargoyles. This one was more sheltered from the rain because of the rest of the building, and this one was just out there getting all of it. And you can see that this one is much smoothed out, right? Here you can see the eye. Here the eye has been lost because it's just being slowly eaten away. Nice, huh? Right? Well, acid rain can accumulate in lakes and rivers, and that can affect aquatic life. Now, in the Midwest, it's not a big problem because the soil has a lot of limestone in it. And so the limestone effect acts to neutralize the acid. So we've got the limestone that's in the earth is neutralizing the acid, much like these poor statues are neutralizing the acid. But in the Northeast, where all of that pollution is going, there's not as much limestone in the lakes and rivers, and so they become more acidic. Trees can also be affected not because that the acid is like eating the leaves off of them, which you look at a picture like this, and that might be the natural assumption. Well, the acid rain is just like dissolving the needles off of them. Actually, what's happening is that the acid is taking the nutrients out of the soil. So as the acid rain falls on the earth, it will dissolve those minerals that are necessary for the plants, and then they'll leach away faster than would be expected. So back in 1990, the U.S. government made some amendments to the Clean Air Act targeting acid rain, forcing utilities to lower their SO2 emissions gradually over time. And so we've seen that this is working. So here's a graph showing concentration in parts per billion from 1990 to 2016. And we see that it's gone from roughly 125, 130 parts per billion down to, it looks like maybe 30 in 2016. And so that legislation is having an effect. And as the acidity of rain decreases, then lakes can begin to recover from the effects. Any questions?